Hi everybody, welcome back. This is the second part of the video, but this is where we actually start the chapter 3.1, investigating quadratic functions in vertex form. This is part one. We're going to look at the parameters of quadratic functions and what happens when we change some of those parameters. So in the first one, we're going to sketch the function f of x equal to ax squared. I have three versions of that. I have when the a value is 1, right here. There's no coefficient, so it's a 1. I have when we have decimal 5, which also can be represented as 1/2 x squared. And then we're going to look at a third when we have f of x equal to 3x squared. You'll notice I have this very nice graph here that you guys have on your page. We use this with a program called Desmas. So I'm going to show you Desmas program. And the Desmas program is it's a great program for graphing equations. So I'm just going to slide that over so you can see putting the function in. All right. So we got y equals, you can put f of x as well. Like you can put f of x equals, it'll recognize that, or you can put y equals. That's really nice. It doesn't have to be in y equals form. That's what I really like about it. But then we're going to graph x, and you'll see x is obviously gives you a linear line, but you click this little button here at the bottom of your page on Desmas, and it'll give you, it's like a keyboard, it'll give you, well, you can do it in square. So you'll notice that we have a quadratic function that you guys are all aware of, y equals x squared. That's the red. That's the middle curve on your page. Then we'll do the same thing. We'll put f of x is equal to 1/2, which is the same as decimal 5, x squared, and it's the blue curve. That's curve number 2 on your page there, the second one, and that's the outside curve you'll see here. So by putting it to 1/2, it usually, you can see that it's pushing out farther. That's because it's called, this is what's called being compressed. It's pushing down. You'll notice if I pick a point here on the original curve, -2 and 4, that's being dropped down to -2 and 2 when I click a point there. Pretty interesting. The y value is cut in half. Neat. And then we have f of x again equal to, this time it's 3x squared. And this becomes long and narrow. This is because you're stretching. You're literally pulling on the graph, and you'll notice, remember that point I showed you before? Trying to get it right down there for you. 2 and -4. When you stretch that up, look at the y value is 4. That's on the original curve. We multiply it by 3. So the y, when the x value is 2, -2, the y value is 12 because it's multiplied by 3. 4 got multiplied by 3, became 12. These are called vertical stretches. So there's the graph. I did it on Desmas. It's DESMOS.com. I'll put that up on the sheet here. So that can be done on Desmas.com. So there's the link. You put DESMOS.com. There's an app actually. It's fantastic for graphing when you don't have the TI-84s at home, the graphic calculators. Remember, this curve here is the blue in the middle, as I showed you. This curve here, so that one there was the blue. This curve here is the outside curve. This was compressed, literally pushed down. That is the red curve, and then the last curve here on the outside is the black curve. So I know I put them color coded. So this is what's called, and we're going to use this very frequently, well, in this section, but we're also going to do it in Pre-Cal 12. This is called a vertical stretch, which sometimes can be short for VS. So this is what we call a vertical stretch. So let's talk about in general what happens here. So if the a value is greater than 1, this is what we call a stretch. And if it's between 0 and 1, this is called a compression, or compresses, if you wish. All right, so the graph compresses. So if the A value is greater than 1, it's a stretch. If the A value is between 0 and 1, this is called a compression. There's also another item, and you're probably thinking it now. I know some of you are. What happens if the A value is negative? So you'll notice I put all these in as negative. Again, I used 1, 2.5. So if your A value is negative, this is actually a separate, these are called transformations. These are a separate transformation. So the vertical stretch, we'll never say the vertical stretch is negative. Vertical stretch is it's always positive, and it's either greater than 1 or between 0 and 1. If it's negative, again, if it's -1, then it will -1 or better, like less than -1, I guess I should say. It's still a stretch, but what happens is the negative causes the graph to reflect. So above, the graphs open upward, as you guys are aware, and I know you guys are familiar with this. We did this in class in Math 11. This says the graph is reflected, and we say this opens downward. So the graph is reflected and it opens downward. You can put that on your line there. And this is called reflection. We call this a reflection. This transformation is called reflection. If there's no questions, we'll move forward. The next is, let's look at what happens when we add or subtract a value from the x squared. So not the x, but we take it and we add or subtract from the x squared. So first one we have here in the blue, that's in the middle, you can see it labeled here, f of x is equal to x squared. That's the one in the middle. That's the one in the blue. Then we have the second graph. That's the one that's a little bit above here. I'll do that one in red. Or I'll do that one black, sorry, or gray. I think it's gray in your sheet. I'm not sure. That's the one here, but you can see it's clearly labeled. And then the last one there is actually red. So we'll color that one in red. So the first one, you'll notice that when you add a value to it, notice it's Q, notice that's the Y value of the vertex, you would be right in saying that. This actually moves the graph up or down. So if Q is greater than 0, so basically it's positive, the +5, that would be this example right here, this causes the graph shifts up. And if Q is less than 0, which means it's negative, the graph shifts down, as you can see in this equation right here. So the effect of adding Q, which, yes, you would be incorrect in saying that is in vertex form, that is the Y value of the vertex. This transformation is called a vertical, because you're moving up and down, translation, not transformation, translation. And short is VT. Usually we call it short. We just say VT. I know I do anyway. In some of the textbooks you'll see we'll do that. All right. Let's look what happens when we add or subtract a value from x directly. So not the x squared, but we actually look at P. Yes, you would be right in saying that P is the y value of the vertex. So you'll see that the blue curve in the middle there, that is the y, that's the original curve, or the parent function, or the parent graph we call it. And that is given by the blue there. And you'll notice when we subtract 1, it goes the opposite way. Because remember, when we had the vertex form, it's minus p. So it's actually moving to the right one. That would be the gray curve that you see. And then the last one, the red that you see, it's plus 3, which means left 3. So the sign is essentially opposite of what you are familiar with. So when we have the graph of the function x minus p squared, it is the graph of the original, the parent graph, or the base function, f of x equals x squared, and it's translated. And we call this, remember, if the p-value is greater than 0, the graph shifts to the right. Now remember, this is important. The p-value, this 1, is p. P is equal to 1 here, not negative 1, because remember, the original is subtract p. So essentially it's the opposite. So if you see x minus 1, that actually means the graph shifts to the right. And if your p-value is less than 1, which would be here because it's net minus a minus 3, this is essentially negative 3, which is at the opposite is plus 3. So therefore, if the p-value is less, which you see here in the red, this graph right here, the graph shifts to the left. And these transformations are called horizontal because you're moving left to right. Not transformation, translation. You may recall this in middle school, grade 9, when you slid, rotated, and shifted. Maybe you remember that. Or slid. I'm not sure exactly what terms were used. And for short, we use HT. That's it for this video. We've just learned 3 transformations. RST. That's all you have to remember. Reflection, stretch, translation. RST. I look forward to working with you in the next video. And this is where we'll go on to page 6, and we'll look at combining transformations. So combining transformations. If you have any questions, please let me know, and we'll see you in the next video. Thank you.